In the final module for this course, we will finish up the dartboard widget setup and add some animations to them. We'll use these animations as visual feedback to let the player know that they scored or that they hit the bonus quadrant. We'll also be animating the red bonus indicator so the correct quadrant is shown, and we'll alter the material of the dartboard to reflect that change. A player will be able to quickly see which quadrant they should aim for and, upon hitting the dartboard, what score they just received, all without taking their eyes off of the dartboard. Let's get started with finishing up the collection of data to display on the screen. Open W-Darts main horizontal. Inside of the graph, create an event construct and get the game instance and cast to our game instance darts. We're going to set this data from our game instance instead of our player pawn as we've been doing, because in a later course, we'll be changing levels and we'll want to make sure that the changed values are persistent between the levels. When working on that logic, we'll also create a way to maintain all our player settings. But again, this will take place in a later course. Get a reference to our struct VR player settings and show only dart game points to win, standard point value, and bonus point value. We want to set the text of our text block goal of game to say, first to score some amount of points wins. So we're going to get a reference of goal of game and set text. And to do this, we're going to need to convert to a string and then append the string to add a few lines. We're going to say to text and then append. So in line A, write first to score, and make sure you include the space at the end. So we have dart game points to win. I'm going to plug that into B. First to score, dart game points to win amount, add a pin, and make sure, again, adding the space. Points wins. Next, we're going to do the same thing for the text block points info. We're going to get that and set the text, convert to a string, and append. Put this into target. For this one, we want to say hit in the red for bonus points. Hit in the red for bonus points. Add 3 new lines with Shift Enter. Then standard points equals, and I'll drag standard point value into B. And then in C, I'll do again 3 lines, and I'll write bonus points equals with a space, add a pin, and plug in our bonus points value into D. Lastly, let's create a new event to display the elapsed time. We'll then call this from BP Dartboard. Create a custom event named update time with an input of time span named new time. Named new time. A time span variable is going to provide us with a structure of integers built to represent the difference of time spans from milliseconds to days. We'll be using it to update the time once per second. Split the time span struct, and from minutes, search for a less than comparison and set the comparison to 10. Plug the result into a select string node. From A, add an append node with a 0 in A and minutes in B. And then drag the new minutes straight into B. Select these nodes and collapse them to a macro named append integer to 2 digits. Let's quickly clean up this macro. All of the integer references I'm going to plug in to just A, so there's only 1, as we only need the 1. And then we're going to take the return value and plug it into the outputs. So going to compile this, remove these two. If we plug the minutes integer directly into the string and it was less than 10, the string will show only 1 digit. For time, we are used to seeing 2-digit minutes and 2-digit seconds. So this little macro will take care of that for us. Duplicate the macro and plug it into seconds. Append those two return values together and set the text of text block time. So we want to append minutes first. We're going to add a pin, and in between we'll put a colon, then seconds will follow. And plug this return into the in text. And now press compile it. Now, back in BP Dartboard, we need our timer events. Create a custom event named Start Game Timer, and then create a Set Timer by Event node. Set Timer by Event. We only need this to run once per second, so set time to 1 and looping set to on. Then promote to a variable named Game Timer. Before the call to set the timer, check if the new Game Timer variable is valid, and connect to a branch. Then only call set timer if false. From the event input, drag off and create a custom event named increment game time. Create a new variable named game over and a new custom event called game has ended. Quickly return to our game mode and call our game over event when we set game over to true. So we're going to grab a reference to our dartboard and call our game has ended. And compile. Back in the dartboard, after game has ended is called, set game over to true. From increment game timer, get a game over and connect it to a branch. If true, pause the timer. If false, call the update time event in the Dart horizontal widget. From new time, promote that to a variable named the same. Working backwards, get a reference of our new time and add it to a time span of 1 second. And compile. Call the initial start game timer at the end of the dartboard hit event. This way, the timer doesn't start until the player has successfully hit the board. Let's play in VR and see how everything looks. Notice on the left side, we have hit in the red for bonus points. Standard points equals 20, bonus points equals 50, all spaced correctly. At the top, we have first to score 200 points wins. Let's fix this so it's 200 is at the end. Before that, let's see what happens when I throw a dart and I hit the board and the timer has begun. Awesome. Before I continue, I want to clean up the strings to read first to score, new line, 500 points wins. So in darts main, I'm going to return to the graph and go to our append. I'm going to say first to score, and instead of a space, I'm going to make a new line, 200 points wins. And on this one, I think that this is a bit too much space. So I'm going to remove remove these two spaces, press compile. Let's get our animations set up. They have already been made and provided, so we just need to tell our widgets when to play them. At the end of the game has ended event, get a reference to WDart horizontals and search for game over. Get game over and connect that to a play animation node. And connect this to the game over. Create a custom event named play hit animation with a bool input named bonus. Animation with a bool input named bonus. Add another play animation node from WDart's horizontal. From in animation, create a select node. We're going to plug bonus into index. On false, we want to play the animation named hit And on true, we want to play the animation bonus hit. And the target, make sure you plug in the main horizontal widget. At the end of dartboard hit, right before the branch, call play animation and plug the bonus hit bool in. Okay, so I know I've talked about this before, but occasionally our blueprints don't refresh right away. So ours right now says new param, but if I were to compile and I need to refresh these nodes, and now it'll say our actual name of bonus. Before I go down to see what the issue is, I'm going to plug bonus in. And down here, I need to place in the target for horizontals here as well, just as we had done below. And compile. Let's see how this looks. So I see the text that we just updated looks all good. And then if you hit the bonus, it's a filled in circle. There we go. So that was the bonus animation. So the standard point, a red circle grows and disappears. There we go. Now that is the standard point. Awesome. The last mechanic we'll make is the indicator to tell us which quadrant is the bonus. Return to Dart's main horizontal. We're going to need a few new variables, including a reference to the dartboard. Let's take care of that first. Create a new variable named BP dartboard and set it to the value of BP dartboard. Before we continue, return to BP dartboard, and when we set the Dart's main horizontal and Dart's main vertical as a variable, let's update our new BP dartboard variable to be a reference to self. So I'm just gonna, from our W main horizontal, I'm going to set BP dartboard. And the value is itself. Back in this widget, create a new bool named rotate. Create an event tick, and after the tick, connect rotate to a branch. I'm going to connect rotate to a branch. Get a reference to image center bonus and create a set render transform angle. And plug this into true. From angle, create a f_inter_2 node and plug delta time into the delta time from event tick. From the target, create a new variable named target rotation. And from interp speed, create a new variable of the same name. We don't need to set defaults to these variables as we're going to create an event to do that for us. Get another reference to image center bonus and get the render transform angle. Plug this into current. From our get render transform angle, check if it is nearly equal to our target rotation to an error tolerance of 0.1. Connect the return value into a branch. If true, set rotate to false. Then check if the BP dartboard variable is valid. If so, we'll call an event. And in false, we're going to check if BP dartboard is valid. So if it is valid, we're going to call an event. Let's make those events now. Inside of BP dartboard, create a custom event named spin board. Add a float input named Y rotation. Add the Y rotation by 90. Rotation. And then we're going to add 90 to the value. Set the relative rotation of the dartboard. Split the struct and plug the sum from the Y rotation into new rotation Y. Select our dartboard and check what our current rotation actually is. So let's make sure we put in our -90 into the X to maintain that rotation while we're calling this event. Create another event named toggle showing bonus with a bool input named show bonus. Add a delay, and from the duration, create a select float node. Plug show bonus into pick A. In A, set it to 0, and B, set to 1. get our dartboard material variable and set a scalar parameter named show bonus. From value, create another select float node and plug show bonus into pick A. Finally, set A to 1 and leave B as 0. And compile. Call toggle showing bonus at the end of spin board and set show bonus to true. Let's return to the widget to finish this up. After the isValid function, call spin board and plug the target rotation into the Y rotation input. Target rotation into the Y. Create a new custom event named setNewBonus with an integer input named newQuadrant. We'll receive the call to run this function and the new quadrant value from the dartboard. What we want to do with this event is tell the widget which quadrant was chosen and spin the image a few cycles and then slow down and land on the chosen quadrant, looking a little bit like this. So using this to display which quadrant contains the bonus points. We also want to be sure that the animation is not repeated, so we will change the speed and the amount of cycles each time. From setNewBonus, first add a delay of 1 second. This is about the duration of the bonus hit animation. After the delay is where we want to set the target rotation. We'll get that value by adding the rotation for the chosen quadrant to a randomly chosen multiple of 360 degrees. So we're going to set target rotation. From target rotation, create an add node. From the top of the add node, create a multiply node. Type 360 in the top and convert the bottom into an integer. If you drag off the float, we want to create a toFloat variable integer. So we're creating a convert integer to a float. From the integer, create a random integer in range node with a min of 4 and a max of 10. What this is going to give us is how many cycles we actually want to have it spin in the time allotted to it. Feel free to play around with these digits here. From the other side of the add node, create a select node. Subtract the return of new quadrant by 1 and plug the result into the index. This is because quadrant 1 will provide a 1, but we want quadrant 1 to be represented by a 0. Create 2 new pins and set them to 360, -90, -180, 90. These are the rotations we need the board to be at for the appropriate quadrant. Now set the interp speed to a random float between 1 and 4. The higher this value is, the faster it's going to rotate. Again, feel free to play with these numbers. Finally, set rotate to true and compile. Return to BP dartboard and call our new setNewBonus event at the end of the dartboard's setNewBonus event. So I'm actually going to get rid of this print string because now we have a way to see it visually. I'm going to get a reference to our W main horizontal, and I'm going to call setNewBonus and provide the new quadrant chosen as the target quadrant and compile. Then call toggle showing bonus and set to false. Let's finally play some darts. Right now, it's indicating to us that the quadrant with the bonus is quadrant 2. Yes, there we go. So I had the bonus. Now it's telling us that quadrant 1 is the chosen, but that came on too quickly. I need to make sure that that goes away. And that's correct. So now you can see how many times it's rotating around. So that can all be changed, as well as the speed with those random float or integer values. I want to find out why the dartboard was showing its image during the rotation of the indicator. So I'm going to open up the W darts main horizontal, and I plugged the isValid into false, and I meant to plug it. I should have. I even said I was going to plug it into true, and I plugged it into false. Now let's see how this looks. So I don't see it, and we're spinning, and now I know that the quadrant is 3, and there's our There's our indicator. I hit the bonus and we're going. All right. I'm gonna call the event after rotate as well from when we set the new bonus. So BP dartboard, I'm gonna call toggle showing bonus to false and press play one more time. Okay, there's the bonus, whoops. Hit it, gone. There we go. This has been a long course and we've done a lot in blueprints and in UMG. But when playing, see how everything comes together to create more than just a dart game. The next big addition to a game like this would be sound effects and music. Keep with the learning path and you'll get there. And just like that, you've reached the end of the 5th course on your virtual reality development journey. Now you should be able to create engaging and performative UI elements to make sure your players know what's happening, where, why, and how. In the next course, Jimmy will be teaching you about how to demonstrate optimal scene management in your project.